So we're back, we've disassembled it. Now, it was a bit inevitable. We were going to get some marring, unfortunately. But, not a big deal. Can be cleaned up. But, regardless, this is what's inside them. Obviously, you have to break this glue. The way to do it is obviously heat. Maybe I didn't heat it up enough, but regardless, this is what we've got inside here. We have obviously the coil soldered to the brass base, which comes up. The electrode, or the central pin, your radiating pin, comes through this capacitor, which this one is marked with, focus, there we are, a 6. So yeah, okay, so I'm guessing it's either a 0.6 or a 6 nanofarad. Now this is quite extended, to be honest. It's quite a large coil. Let's get the one from the so-called 7900 to compare. So this is the coil from the 7900. Obviously, it's a lot shorter. It sits further down or closer to the base. What's that? It's got like an extra turn. So one extra winding, I guess. When we look at these solder joints, the solder joints are not actually that bad, to be fair. They could be better, but obviously, I mean, this is still up this end. They haven't snipped the end of the capacitor. Obviously, again, it's tapped, so it's a tapped induction coil, and this obviously comes up towards your antenna. So there's not really much that could go wrong in there other than solder joints, and well, the solder joints aren't too bad, apart from the one that was, or the brass piece that sits on top of that. So obviously this is the brass piece from the 7900, the supposed 7900, which went on top of that one, as you can see there, and that was the length of that one. They generally seem to come to about the same height. If we look, this one here, they are actually the same. They do come to the same overall height. They're just effectively loaded up and down depending on the type of antenna that sits on top of them. Obviously, this one being a shorter antenna, it's only a 2-element rather than the 7900, which is a 3-element. And obviously, I mean, this is the tube. We marred a little bit on the edges there to get it off, but it's still the same thing. Threaded in there. It looks brass again. So it's a brass or bronze. It's probably brass. Threaded at the top and at the bottom. Obviously that goes over the top, and this obviously threads together. Push the capacitor back out of the way. That thread glue they're using there is a bit whatever, but yes, as you can see, that's what that is. And obviously this is a retained plastic cap, which I'm thinking to make either out of acetal plastic, maybe, because this is nylon. It doesn't handle as much of the heat, as you can clearly see. It's just the soldering or whatever it has caused the plastic to part on there. But yeah, as you can see, that threads into the top. So I mean, it's a pretty simple design. dropping one of these coils in a bath of water maybe and letting it sit there overnight to see if they rust would be another thing. But they're not magnetic, so, and you can solder to it, so it can't be steel. So I don't think they'd corrode. I mean, the brass would. I mean, this is just plain brass, but they've used glue on the threads, which is obviously going to affect the antenna's performance because it's got glue in the threads. It's not going to be a consistent connection, and that's what I'm tending to find with these cheap Chinese, which I don't believe are knockoffs, but we'll call them knockoffs anyway. And knockoffs is an awkward word. I mean, generally for a cheap antenna, you're pretty much getting a reasonable setup kit, and you could, you know, repair these and, you know, build them yourself and guarantee, you know, do all the soldering and resolder them up, which is what I'm doing, of course. And to guarantee you're getting a better quality of these, you know, I mean, it's a lot of messing around, but, you know, £20 versus, you know, I think this 7500 is 69, 70 quid. In the UK, including VAT. So, you know, I mean, this, there is a customs charge. You have to pay the £8 raw mail handling fee and about £3.25, which is the VAT. And then you've got to piss around with it. So, I mean, this is generally what we're looking at. And I haven't seen anybody been making any YouTube videos to explain these. So I thought I'd buy them, make some YouTube videos, get them out there to people so that they can see what's going on. Obviously, the reason I couldn't measure a capacitance effectively between the electrodes, or the centre pin and the top electrode, was because we've actually got an induction coil in the middle. And obviously, as I say, I don't quite know, obviously fingers and all the rest of it or whatever, I don't quite know exactly what else would interfere. The only thing you'd be able to do while this is a sealed unit is measure your inductance on here with like an LCR meter, or set up a resistor. Let's say a 50 ohm dummy load, so you've got a perfect 50 ohm, use a network analyzer, and then obviously put this inductor from the base to the tip, or your brass tip, which would be, because yours would be closed if you hadn't opened it up, and basically measure where the resonance is coming, where you get your resonance, and take the frequency from your network analyzer that it becomes resonant at, and 50 ohms. And then calculate out, so you can reverse the the resonant induction formula, so that it actually calculates out the inductance. So you can get a rough idea of what the inductance is on here. You can do a more accurate measurement. You can run it through an oscilloscope and measure your ringing of the set in a square tooth, basically, and then measure the ringing frequency on the oscilloscope. You need a 2-channel oscilloscope minimum, really, for that. But yes, and there's several different methods you can measure inductors. You can have an LCR meter. An LCR meter across here would actually measure the inductance of this. But yeah, so, I mean, this says 0.6 on the 7900s, whatever. That actually says 6R8 on the bottom of there. It's very small. It's a small beaded capacitor. But yeah, you can't, camera won't focus too well on it. But that says 6R8 on that one. I mean, for argument's sake, let's see if we can get a capacitance reading off my multimeter. I think I'd go up to about 100 picofarad as my max readable values on this. So let's just try from the one side to the tap of the coil there. Staying allows about 0.38 nanofarad. Which is strange when it says 6. Just says, or could it be a 9? No, it's no, it can't be. No, it has to be measured that way up. So it's 6. And that's a 6, and that's 0.38. This, obviously, the markings on here, the 6 are 8. So let's try and see what we get. OL. Huh. Dead short. So this capacitor on here is actually dead as a dodo. So this capacitor is not working. Surprise, surprise, surprise. So check continuity. A 1.5 mega ohm. But is that catching my fingers? It probably is. Yeah, without my fingers in the way. 0. Open circuit. Let's put the buzzer on. So that capacitor is open circuit. Flick it to capacitive readings. Oh, and now we get... That's just stray capacitance, which was weird because that's what I was getting yesterday. It's not got an actual, not figuratively reading it. So that's 0.35 nanofarads. Let's try and measure this one again without the fingers. Okay, so we don't actually get a reading because my meter's fluctuating with a stray reading here. $3.9, take it away, 3.3. Let's try and short it out. There's no charge. .35 nanofarad. Strange for a marking of 6, so could be in circuit interference. There's a lot of grinding on there. It's as if what they've done is they've took a manual angle grinder and just angle grinded it. Aluminium file or filings from it. So yeah, look great, but yeah, the thing is, these you could, as I say, with all the messing around. As I say, I know where that black's from. That's the black from the plastic cap in the thread. But yeah, with a bit of messing around, you could turn these into an actual reasonably good working antenna. I mean, it's a solid build. It's still quite solid with the brass whatevers, but yeah. I think the point to make here is that obviously you buy these cheap antennas, don't just go and stick them straight on your setup and get started with them. They're going to need some work. But if you're interested in saving that tiny bit of money, which is, well, in the UK, it's actually a bit more than just a tiny bit of money. If you're interested in saving a bit of money and you want to put the work in, you can see what work's required. This little tiny bloody bit that they haven't trimmed off of the capacitor is doing my nutting. So let's get rid of that. Obviously, the capacitors don't seem to read much. Now, this insulating wire is a glossy one, yet the one that's in the 7900 here is a more traditional type. So there are differences, different components, inconsistencies. All in all, it'll be interesting to work with. Now, I've ordered another one of the 7900s, which are these ones, because I want to actually see whether it's actually identical or not. There could well be sort of differences even from the same supplier. And that's what I'm believing. There's going to be some form of difference between these, the one that originally yesterday I taken to pieces, and the one that's going to arrive. So we shall see on those ones. Next videos to come up or whatever are actually going to be measuring the coils, these things. This is the capacitor unit or mid-loading. Honestly wondering how they're actually put together, to be perfectly honest. They're assembled somehow, so they get them together some way, shape or form. But again, I can't read a value off these either. I'm sure my meter's working on capacitance, but might have to get a known good capacitor and see what it is. I mean, it's possible that these capacitances are out of range of this meter. It measures some capacitance, not all of it. So let me just see if I can get any reading of capacitance off this loaded piece here. Well, according to this, I do. I get something, but we're in capacitance. Climbs, fluctuating up and down, approximately around 0.47, 0.41, 0.5. It's quite all over the shop, to be perfectly honest. It's interesting. There's a 0.34, 0.35. Fluctuates. Okay, well, we shall have to do further investigation to them. I believe this is the same plastic that is used on the other parts of the antenna, so that could be cut out. Take a look what's in there. Or is it an actual insulator that goes all the way through? It's threaded in. I bet they're probably, again, threaded. I would not be surprised if that is the case. In fact, we could test for that. Let's have a look. Oh, they are indeed threaded together. not overly tightly either, not like the base of the antenna. So let us uncap the cap. Look at that. There is some glue in there, not bleeding much though. Mind you, there is nothing in there. It's just the plastic. There is absolutely nothing whatsoever in between this. I actually thought there'd be a capacitor. That's interesting. Let's get the middle plastic bit off. Again, quite easy to unscrew actually, it's turning out to be. It's still too tight for one's fingers, but plumber's pliers always works wonders. Oh well, don't worry, I will get a better camera setup than this. It's just my phone on a tripod at the moment. So, but yeah, right, here we are. That is the entire plastic piece out. So effectively then, what their idea of a middle capacitor is literally, what have I done with the other? Is literally just these two pieces. And it's the distance that they're spending apart. So effectively, that is your capacitors. Two pieces of aluminium, such and such, such and such. Well, there you go. That's all that is. So yeah, that's interesting to know there. Obviously, I mean that. Look at that. It's obviously bent as an arm bob note coming out of there. Very, very poor, that one. But I wonder if these screw off just the same. Would be interesting. We can have a look. There should be a coil inside this one. But, well, I don't know. Say, given the surprises I've seen in so far, okay, so this one actually is a coil. You see, that's came off like that. Again, there's glue in the threads, which isn't going to make a great connection. Because, as I say, I'm sure this glue's non-conductive. So, yeah. So, right, okay, let's see if we can take the other end off. I'm guessing that's just a thread either side. Yeah. It is, it's a thread either side. Oh. And that one doesn't have a thingy bob. So that one's soldered straight onto the thingy, because there's the coil inside there. So I'm guessing that is either stuck in there or is it threaded in there? This is the question. Good question. Let's see if we can find out. Can't break it any further. Oops. Not doing the thread any good, let's put it that way. But let's get her out. Out comes the coil. There we are. So it is all threaded together. Obviously threaded at that end. Marred the thingy-me-bobs. Again, brass. But these coils, look at that. What's the point of a coil if it's half of it is blobbed over with solder? Worrying, that, isn't it? Yeah. So, as you can see, that's the outcome of a £20 antenna. That's what you get. Corrosion problems? Doubt it. Performance issues? Most definitely. But to be perfectly honest with you, I think you'd find the same quality and whatever with the diamond type, to be perfectly honest, I reckon. Well, then again, maybe not. Maybe someone's got an original one they can take to pieces. And we'll see if it's built the same way. But yes, that's how they're built. So we shall investigate further at a later time on what the values are electrically of these antennas. But you can see they're particularly not built too bad in quality, but they are literally assembled and soldered pretty bad. Not impressive. Not the type of thing that you'd want to say you could trust without blowing your final stage of your transmitter up. So, anyway, that's enough from me tonight. More to come on the Diamond Nagoya Chinese-made, not so legitimate diamond / Nagoya antennas. 7 3s, catch you again.